whatever. If we don't get it, we don't get it. We got Leah Zami here in the house. She's going to be leading you. She actually put this curriculum together. She's going to be leading K-Sing through it. Kay.
Yeah.
What's up? You ready for a good lesson?
Psych.
All right, fine. In front of us, we have the full 12 lessons. Today, we're just going to be jumping into a few of them, but I guess you watch it. It doesn't have to do with the days that we have it. All right, fine. Let's just jump right in, Leah. You can take over.
Okay, great. We're going to start with the first chapter, Matter and Measurement. How do I scroll? Okay.
You flip.
That's fine.
Next on the...
Great. Okay, matter and measurement. So the first thing you need to know is how to classify matter. Here's the words that they actually use on the Regent. If they ask you a question about what can be broken down by chemical means, you need to know elements cannot be broken down by chemical means. Like it's sodium, it's staying sodium. If you have a compound, it can be broken down. If carbon dioxide could be broken down into carbon and oxygen. And you need to know the terms has a fixed ratio, 1 carbon to 2 oxygen. Then you need to know the 2 types of mixtures. Homogeneous mixture or homogeneous, however you want to say it, you can't see the different parts. If I mix salt and water, you can't pick out the different salt particles. And a heterogeneous mixture is when you can see the different parts. Your teacher may have told you like a salad, I could pick out the lettuce, pick out the tomato, things like that. Okay? You need to know, it's not in any of these questions here, but for any question on the Regent, the diatomic element, di meaning 2, you've heard of that prefix before. They don't exist by themselves. They're always existing in pairs. H2, O2, N2. You need to know Hankelbrief. Your teacher may have said Hankelbrief. Remember those. Okay. Here, let's go through some questions. Which substance cannot be broken down by chemical change? We just said it's an element. So pick one of these as an element. If you look at your periodic table, it's going to be zirconium. Okay. Compound is a substance composed of 2 or more elements that are same words as before. Chemically combined in a fixed proportion. Great. Which sample of matter represents a mixture? Now you're looking for 2 things together. So aqueous ammonia, you'll see the term aqueous a lot. Aqueous means water. So if you have aqueous ammonia, it's ammonia and water. That's a mixture. Decomposed by chemical means, same thing. You're looking this time for a compound. Which substance cannot be broken down? Same thing. Look for an element this time. Now, which sample of matter is a mixture? You're looking for 2 things together. Again, with the aqueous, the little AQ at the end of the KBr means that it's aqueous. It means it's KBr in water, so that's a mixture. And then the ratio of chromium to iron to carbon varies among the different types. If it's variable, we don't have a compound anymore. This time we have a mixture. Okay. All right, now we have a short answer, a lot of words. But we don't have to even read them. Explain in terms of particle distribution why a coolant solution is a homogeneous mixture. So if you look at the slides before, homogeneous mixtures, uniform particle distribution, meaning it's the same everywhere. Okay, you don't even have to read all of that whole paragraph that they give you. All right, now particle diagrams. There are 4 types that you need to know. If you know all 4 of these, you're going to get all the questions right. So you have an element. Means you can only have, give you a key atom of 1 element. That means you should only see 1 element in there. A diatomic, like we said before, exists 2 together, so you want to have 2 of the elements together. A compound needs to be composed of 2 different elements, so you're going to have 1 white, 1 black. And then when you have a mixture, you need more than 1 type of thing. So you need, you could have an element, you could have 2 different types of elements together, an element and a compound, 3 different compounds, whatever. Anything that's not one thing by itself. So now let's go to the questions. Given the particle diagram, which type of matter is represented by the particle diagram? This would be a compound because you have 2 elements stuck together. Next, which particle diagram represents a mixture of 3 substances? So now you're looking for a mixture that has 3 different things. That would be number 2. You have the diatomic element of the 2 white, the diatomic element of the 2 black, and then you have a white and a black, a compound. All right, now they ask you to draw it. Use the key to draw at least 5 particles in the box to represent the phase of the product. So a carbon dioxide molecule in the gas phase should be very spread out. We're going to talk about gases later, so you're just going to draw 5 carbon dioxide molecules spread out. Then in the box in your answer booklet, use the key to draw a particle diagram to represent the 2 phases of carbon dioxide in a newly filled tank. Your response must include at least 6 molecules of CO2 in each phase. So the two phases that are there are the carbon dioxide gas and carbon dioxide liquid. So we'll see later again, gases are more spread out and liquids are more closely packed together. So you're just going to draw, 6 of each. All right, now you need to know 3 main ways to separate mixtures. The first way, you guys know filtration. You separate heterogeneous mixture. If I have sand and water, I put it through a filter, I'm going to be left with the sand on top, the water is going to go through. Next, if I have a homogeneous solution, salt and water, if I filter it, everything's going to go through the filter. So if I let it sit there and let it evaporate, the water will leave and I'll be left with the salt. And the last one is distillation. That's when you have 2 liquids. If I give you a mixture of apple juice and orange juice, I tell you to separate it. You can't physically pick it apart with your hands. So what we do here is we use a difference in boiling points, meaning the orange juice may boil at 40 degrees and the apple juice may boil at 100 degrees. So if I heat it up, the mixture, to a temperature of 40 degrees, only the orange juice is going to boil off. And what are we going to be left with? The apple juice. The orange juice is going to go somewhere else. The main example that they give you on the test is ethanol and water. You need to know we use difference in boiling points. Okay, differences in which property allows the separation of a sample of sand and seawater. The particle size, right? The water is going to go through and the sand is going to stay on top. A mixture consists of sand and an aqueous salt solution. Which procedure can be used to separate the sand, salt, and water from each other? So you're first going to want to filter out the sand. You'll be left with the sand. The water and the salt will go through, evaporate the water, and you'll be left with salt. So that's answer 4. Okay, next is significant figures. The students may have learned it for a long time. They maybe get one question as part of a titration question, usually not on their own. So the rules, they may hate it, but it can be broken down very simply. So any non-zero number, significant. 1, 2, 3, 4, 5, 6, significant. Zeros that are in between 2 non-zero digits, also significant. Leading zeros, meaning zeros that come in front of the significant number, never significant. So 0.04, those 2 zeros, not significant. Trailing zeros are only significant if there's a decimal somewhere in the number. So there's no decimal in the 100. It has 1 significant figure, but 100.0, 4 significant figures. The rule for multiplying and dividing, you need to go according to the number that has the least number of significant figures. So 10.0 has 3, 0.45 has 2. Our answer has to have 2. So here's part of a titration question. I pulled it out, but later in titration you'll see more of them. So it says during a titration, 100 milliliters of acetic acid is completely neutralized by adding 12.50 milliliters of, long thing. State the number of significant figures used to express the volume of acetic acid. So if we go back, they tell us 10.00 milliliters of acetic acid. That's going to have 4 significant figures. All those zeros are significant because there's a decimal in the number. All right, the last topic for chapter 1 is density. Density, you need to know its formula, mass over volume. It's how much matter is packed within a certain volume. So if it's tightly packed, it has a high density. If it's loosely packed, low density. The density of an object determines whether it will sink or float in a substance. So the things with the higher density, it's going to be heavier. It's going to sink to the bottom of the things with the lower density. So if we look here, which property will increase when the sample is cooled at 72 K? So it's going to be the density, obviously because it's in the density chapter. Explain, so at standard pressure, water has unusual properties. Okay, you can read the whole thing. Explain why H2O solid floats on H2O liquid. So in the paragraph, it tells you that H2O, when H2O freezes, its particles actually expand, which makes it less dense because now it's less tightly packed. So H2O solid will float on the liquid because it's actually less dense than the liquid. Then we have the next question. The densities for 2 forms of carbon at room temperature are listed in the table below. Carbon graphite has 2.2, carbon diamond 3.513. Compare the number of carbon atoms in a sample of graphite and a sample of diamond. So when they say compare the number, one of them is going to have more, one of them is going to have less. The one with the higher density is going to have more because they're more tightly packed. So you would say the carbon graphite sample has less particles or less carbon atoms than the carbon diamond.